Hello, students. I want to talk about the chemistry of life. That's something that's very important because basically, you can really break pretty much anything down to the basic chemical level. All organisms, all living organisms on planet Earth, are atmosphere, oxygen, nitrogen, carbon dioxide, carbon monoxide. Concrete, asphalt, oil, all these things are made up of chemicals. Now, as you see here, the basic structure of an atom. So, as you see here with this atom, change colors here. All right, so you have the nucleus. All right. So here in the nucleus, you have both the protons that has a positive charge and the neutron. All right. So again, proton and neutrons. Proton has a positive charge, whereas neutron has a neutral charge. And on the periphery, orbiting around, okay, is the electron. The electron has an overall negative charge. So again, proton, neutron, and orbiting around is the electron. So basically, you can look at the proton, neutron, which is the nucleus of the atom. You can kind of, I guess, maybe look at it on a grander scheme, whereas the nucleus of the atom, where the proton and the neutron resides, it's like the sun. And the electrons are simply just the planets revolving around the sun. Again, here's another schematic, just further emphasizing what's going on here. So again, you have the nucleus, where you have the protons and the neutrons. And out here on the periphery, you have what we call the orbitals of the electrons. Now let's get into some of the terms. First of all, you have the atomic symbol. Atomic symbol is simply just one or two letters that represents elements. I'll show you some examples, whereas atomic number is the number of protons in an atom. And finally, the atomic weight, and that's the actual weight of the atom. Okay, so the atomic number, a lot of times you'll see on the periodic table, all right, here, the atomic number is at the top. The atomic symbol, it says element symbol, but we usually call it the atomic symbol. That is going to be represented by one or two letters, and they're based in Latin. They'll be usually in the center, and the atomic mass or the weight, you'll see that at the bottom. All right, so here's a perfect example here. The atomic number, again, the number of protons. It says here the number of electrons, but really more accurately, that number can vary. So again, and what I mean by that number can vary, the number of electrons relative to protons can vary. So always remember this, the atomic number is really based upon the number of protons, okay? And then the atomic symbol, so here with carbon, it's a single letter, and then the atomic mass, and that's simply just the mass or the weight of that one carbon atom. All right, the periodic table of elements. So again, here, you have hydrogen, and then over here you have helium, and then lithium, sodium, potassium, calcium. Just a whole lot. So really the atomic symbol is simply represented by either one letter or two letters. If it's represented by two letters, the first letter is capitalized, whereas the second letter is always lowercase. So the atomic symbol either by one or two letters. And again, as you see here, let's see, let me just pick one, gold. Okay, 79. So right here is gold. You see here, represents gold. All right, so gold has 79 protons. Now, it very well can have 79 electrons and neutrons, and oftentimes it can, but then you can have different species where that it actually does not. That number can vary. So on this periodic chart does not have the atomic weight on the bottom that's normally seen. But again, like I said, the atomic number that's above it, all right, magnesium, iron, cobalt, nickel, copper, so on and so forth. Again, that represents the number of protons. All right, so here you have something that's called an isotope. All right, so an isotope is where the number of protons relative to the number of electrons, may vary. So typically you have the same number of protons and neutrons. Oh, I'm sorry, I may have said electrons. Neutrons vary. So typically, you have the same number of protons and neutrons. So for instance, with carbon-12 here, you got 6 protons, 6 neutrons. All right, mass number of 12. All right. However, you have carbon-13 where they have 6 protons and 7 neutrons. But it's still going to be carbon because again it's 6 protons. All right, so even though the neutron numbers can change, it's still at the end of the day carbon because it still has 6 as the atomic number, so 6 protons there. So that's going to identify it as carbon. So this is called an isotope, where that you have a different number of protons relative to neutrons. That's an isotope. That's an isotope. And you see, basically has the mass numbers. So these are isotopes. Again, different number of protons relative to neutrons. Whereas with ions, okay, it's different. Whereas you're going to have a different number of protons relative to electrons. Okay, so for instance, for oxygen. All right, you have 8 protons, 8 neutrons, 10 electrons. But still, at the end of the day, it's still oxygen because it has 8 protons. So in this case, you have an overall negative charge, an overall charge of -2 because electrons have a negative charge. Again, remember, electrons, negative charge, protons, positive charge, and then neutrons has a neutral charge. Okay, here with chlorine, 17 protons, 17 neutrons, 18 electrons. Again, that's an ion. All right, and you can see the same here for these other examples. Iron, 26 protons, whereas you have 24 electrons. Again, that is an ion. So again, an ion has a different number of protons relative to electrons. All right, and skip that. We didn't really get into molecules versus compounds, but well, yeah. Molecules formed when 2 or more atoms are joined together. Chemically, compounds is a molecule that contains at least 2 different elements. Okay, so here are some examples. So these are molecules. All right, 2 or more are gathered together, and then they're the same. So you have H2, you have O2. That really should be probably a subscript, kind of like this. And I'm using my mouse to try to write these there. So it's not an art project. Sorry, kids, not an art project there, but here you go. Okay, so that simply means that, hey, you have 2 oxygen molecules. They are a diatomic molecule. So it's something like that. That's a bond, double bond, oxygen, oxygen. All right, and then nitrogen. Okay, whereas up here you have actual compounds. So there are 2 different elements that are bound together. So that's different. So molecules, compounds, right? So pretty much all compounds are molecules, all right, per the definitions, but not all. So all compounds are indeed molecules, but not necessarily all, but not all molecules are compounds. Or maybe I should say that all compounds are also molecules, but molecules are not compounds. So again, compounds have 2 or more elements along with a different element here. Okay, like here, 1 part carbon with methane, 4 parts hydrogen. Right. So some of the chemical bonds, covalent bonds, is based where you have sharing of electrons. So this is a perfect example where that you have 8 electrons in the orbital. All right, and a lot of times they kind of just like want to share, so you have the sharing thing going on here. So these two atoms are actually forming a covalent bond. Ionic bond is formed when you have two ions forming a bond with each other. So you have a +1 and a -1. So it's kind of like opposites attract. And you have these two guys together here. So that's sodium Na chloride, Cl, sodium chloride. That's table salt. So that's the chemical bond there. All right, talked about the covalent bonds. Again, another example of covalent bonds where they have a sharing of electrons with the electrons from carbon, and then the electrons from hydrogen. So right here, this is a situation where it's CH, and here's subscript 4. Hydrogen bonds, usually weak bonds, where you positively charged hydrogen atoms to other negatively charged atoms there. Then you have peptide bonds, and this deals with amino acids. Amino acids are, of course, found in a lot of different type of things, food products, particularly things that are high in proteins, because amino acids, you put a whole bunch of amino acids together, which you call monomers, but that's just a fancy word, but a whole bunch of amino acids together to form proteins. So then you can also have peptide bonds, which too is a chemical bond within itself. All right, thank you.